Start the recording. Okay, so we're going to get started in 8.4. Now, before we start actually working some of these problems, I'm going to take it back a couple of sections to see what's actually happening in the problems that we're doing today. So remember a couple of sections ago, we were either given a written out polynomial function that said x cubed minus 6x squared plus 7x minus 5, something like that, and asked to find the zeros, or we were given the information like this. We're given information like this and asked to find the zeros. What did that mean? That meant that it wanted to know where did, if I graph this function, where would it cross or touch the x-axis? So I would be asked to find the zeros or the x-intercepts from these factors. So we'd be given the factors, and what would we do with these factors? We would set them each equal to 0. And this one would just be x. And then we would do what? We would solve them each for x. So what would happen here? I would have to subtract the 7 from both sides, and I would get x equals -7. Here I would have to add the 5 to both sides to get rid of that -5. And here, this one would already be solved, right? The x is just equal to 0. Those would be the 3 x-intercepts or the solutions or the zeros. Remember, all 3 of those terms are interchangeable. They all mean the same thing, okay? These numbers right here had to do with the multiplicity of each zero or each x-intercept. And the multiplicity just tells you whether or not the graph crosses or just touches the x-axis and goes the other way. Right? If it was even like these, that meant it was an x-intercept that just came and touched the x-axis and went the other way. If your multiplicity was odd, like this one, that means that this x-intercept would cross all the way through the x-axis. Today, what we are going to be given is the zeros, asked to work it backwards to the factors, and then multiply the factors together to get the full-on written-out polynomial function of the graph. So let's look at our zeros compared to the factors. If my 0 was -7, why did it end up being -7? Because I took the factor, set it equal to 0, and solved it. In the process of solving it, I had to do what? Subtract the 7 from both sides. That's what gave me that -7. So if my 0 is -7, that's because it came from the factor x plus 7. If my 0 is 5, because it came from the factor x minus 5. So we're going to need that knowledge to work these problems in section 8.4, because we're going to be given this information and asked to work backwards. So let's look at number 1. On number 1, it tells me find a polynomial function of degree 3 with real coefficients that has the given zeros. So let's see, the zeros that it gives me are -3, 4, and -5. So it's saying there's a graph that has these 3 x-intercepts. What's the polynomial function that this came from? So we're going to go backwards. So let's see. If this is a 0, what factor did it come from? It would have had to come from x plus 3, right? If this is a 0, what factor did it come from? X minus 4. What would this one have come from? X plus 5, right? See why I did that explanation at the beginning that explains how x plus 3 turned into a 0 of -3, right? Because if I set this equal to 0 and solved it, it would have given me -3. So I'm going backwards. Once I turn my solutions, or zeros, into their factors that they came from, to get the long drawn out polynomial function now, I'm going to have to multiply those 3 binomials together. Here's where it gets tedious, okay? It's not hard work. I'm just going to be multiplying and then combining like terms. It's just messy work that needs to be kept organized so that when you're combining like terms and like that at the end, it's not all over the place. So I'll FOIL this. My first, x times x gives me x squared. X times -4 gives me -4x. Then my inner and last, positive 3x. Positive 3 times -4 is -12. What happens with the -4x and the 3x? Can I put those together? Sure you can. They're like terms. So I've got x squared. -4x plus 3x is just -1x. Bring down the -12. So that took care of multiplying the first 2 binomials together. Now what do I have to multiply this now trinomial with? That x plus 5. So again, a lot of distribution work and just areas that are open for just real small, simple sign mistakes and things like that. So let's multiply this one times that one. So x squared times x. There gives me my x to the third. X squared times positive 5 is positive 5 x squared. Negative x times positive x gives me -1x squared. Let's see, what do I have now? Negative x times positive 5 gives me -5x. So I've distributed the x squared. I've distributed the negative x. Now I got to distribute the -12 to both of those. So -12 times x gives me -12x. And -12 times positive 5 is -60. And then clean this up. So I can put my x squareds together, and then I can put those x's together. So I'll bring down my x cubed. The x squareds, I've got positive 5 and -1, which gives me positive 4. X squareds. Put your x's together. -5 and -12 gives you -17x's. And then drop down your -60. Now, you'll notice when you're typing in this answer that there is just one blank. The only thing that is blank is this right here. So your answer to that problem is just 4, because it has all of this written out for you and says, what's this missing number? And the only way you're going to be able to get to this number is by doing, there's no shortcut here. Okay? So it has everything written out for you, even the x squared and the plus. Now, before we get into a problem like number 2, we need to go back. So some of you for like transitional algebra, I think we talked about i's a little bit earlier. And we need to remind ourselves that anytime I see an I squared, I have got to change it to what? -1. Anytime you have I squared, you need to change it to -1. Because now some of the zeros that it's going to give me at the beginning are going to have i's in them that we're going to be multiplying together. So we're going to run into some I squareds now. All right, write a polynomial function in standard form whose zeros include 1, 3i, and -3i. Now, when we have zeros, I will tell you this, and this will become important on Wednesday. If you've got a +3i as a solution or a zero, -3i is automatically going to be 1. Because they have to come from what's called conjugate factors. Okay, let's look at what this would look like written out as its factors, just like we did on the last one. If this is the solution or the zero, what factor must it have come from? X minus 1. If 3i is a zero, what must it have come from? Same process, x minus 3i. And if -3i is a zero, it came from x plus 3i. Now, whenever you have binomials that have i's in them on this kind of problem, you want to multiply those together first. Remember, multiplying you can do in any order, right? Because 3 times 2 is always going to be the same thing as 2 times 3. It doesn't matter what order you multiply numbers in. You will end up with the same thing at the end. If you have i's, or like on the next problem, square roots, they're going to have conjugate factors, which means the binomials are going to be the exact same except for their sign in the middle. And when you multiply FOIL binomials that have that situation, they clean up a lot. A lot disappears, cancels out, and your i's are going to go away. Let's see how that happens. So let's, again, we'll bring this one down in a minute. But if you've got situations with i's, do those parentheses first. Let's see. X times x gives me x squared. X times 3i, so that this is going to give me positive 3ix or 3xi, however you want to write it. Look what your inner gives you. -3ix. And then what's your last give you? -3i times positive 3i gives me -9i squared. This cleans up a lot. What happens to your middle two terms? They just cancel each other out, right? If your binomials are conjugates of each other, like these two are, that's going to happen 100% of the time. What does this turn into? What is I squared equal to? Anytime I see I squared, I have to change it to -1. So this right here really says -9 times -1, which makes it +9. So in other words, if you have an I squared hooked onto your term, that's essentially multiplying your term times -1, which just does what? Changes the sign of that term. So what am I left with here? All I'm left with is this x squared plus 9. So that's why you want to multiply these two parentheses first. You definitely do not want to multiply this parenthesis times this one. That leaves you with a mess. Multiply your I parentheses together first because your i's will cancel, your I squared turns into a plain number, and then I have a much prettier parenthesis left. Now, I still have this x minus 1 that I have to drop down and FOIL this. X times x squared gives me x to the third. X times positive 9 gives me positive 9x. Negative 1 times x squared gives me negative 1x squared. And your last negative 1 times positive 9 is negative 9. Now, our result doesn't need to have any terms combined because there's not any like terms, but the way that I would straighten this out is you do want your exponents in descending order, which means what term should come after the x cubed? The x squared term. So let's just rewrite this. X cubed, then the minus 1x squared, then the plus 9x, and then the minus 9. Now, here's the weird thing about this problem. That's the answer. When you're filling in, it's already got everything except it's got a blank right here, a blank right here, and a blank right here. It's already got the minus here for you. So you're just putting in a 1 there. See what I'm saying? It's kind of weird. It's already got the plus here for you. So you're just putting in a 9. And on that last one, it's got the minus for you. So you're just putting a 9 in that box. All right, number 3. Find the polynomial function of lowest degree with the zeros square root of 7, negative square root of 7, and 5. So here's my zeros. So let's take them backwards to their factors. So this one would be what? X minus the square root of 7. X plus the square root of 7. And this one would be x minus 5. Now remember, if there's any conjugate factors, you want to multiply those together first. Who is automatically going to have a conjugate factor? Any factor that has an I or a square root. So look at these two factors right here. They're conjugates of each other because one's x minus the square root of 7, one's x plus the square root of 7, which means when I multiply these two binomials together, a lot of stuff's going to clean up. I'm going to have things that cancel, and my square root is going to turn into a plain number. Let's see how that happens. So let's see, I've got x times x, which gives me x squared. X times the square root of 7. This x is not underneath the square root, right? It's not underneath the little radical symbol, which means I can't put it under there. I just have to keep it outside of it. So that's just going to be a positive x in front of the square root of 7. This one will be a negative x in front of the square root of 7. And then my last, negative times a positive gives me negative. Multiply the square root of 7's together, which gives you the square root of 49. Because both of those 7's are underneath the radical, if both of them are underneath the radical, you multiply those 7's together. That's where I got that 49. Let's clean this up. What happens to all of this in the middle? Positive x squared root of 7 and negative x squared root of 7 cancels. Again, that's going to happen 100% of the time when you multiply binomials together like that. So I've still got this x squared. What does this turn into? Minus, what is the square root of 49? Plain old 7. So that's how that cleans up. Since that was a perfect square, I could go ahead and take the square root of it and change the square root of 49 into a 7. So that multiplied those together, so I'm done with those. Now I need to bring down this x minus 5 and multiply it. So x squared times x gives me x to the third. X squared times negative 5 gives me negative 5 x squared. Negative 7 times x gives me negative 7x. And negative 7 times negative 5 gives me positive 35. So when I'm looking at these, I have x cubed, x squared, x constant. So everything's in the right order. And none of them are like terms, so I can't even combine any of them. So that's as far as that one goes. Number 4. All right, number 4, my zeros are negative 1/2, 0, and 3. All right, working this backwards. What would this 0 have come from? Well, since it's negative 1/2, it must come from x plus 1/2. Yep. This one is 0. What factor did that come from? How do you get your 0 to just be a 0? Well, you would just have the x, right? That's where we would get the 0 of 0 when we have x equals 0. And what does this last one come from? X minus 3. Now remember, when you're multiplying, you can go in any order that you want. It doesn't matter what order you're going to do. And I don't even know why I'm choosing this. I think it's because I'm avoiding that fraction. And this just looks easier to me to just distribute that x. Because all I have to do is end up multiplying all 3 things together. So let's see, if I distribute this x, I would get x squared minus 3x. So I've taken care of that. But now what do I have to multiply this result by? So what I'm trying to avoid is still here, right? So now I'm multiplying these 2 binomials together. Let's see what that gives me. X times x squared gives me x to the third. X times negative 3x gives me negative 3x squared. My inner 1/2 times x squared gives me positive 1/2 x squared. And then my last, I have 1/2 times negative 3x. Now, remember, when you're multiplying fractions, that's not as bad as adding and subtracting. Because when you're multiplying, you don't have to have the same denominator, because these definitely do not. What am I multiplying? I'll just write it out over there. 1/2 times negative 3. I think of the negative 3 as being over 1, and then you just go straight across on top and bottom. You don't care about common denominators. So up top, what am I going to get? Negative 3. In the bottom, 2 times 1 is 2. So you get negative 3 over 2. So 1/2 times negative 3 gave me negative 3 over 2. And what do I have at the end of it? An x. So looking at my end result, I do see that I have x squareds in the middle that can combine. Now, I do have to have a common denominator. But here's the thing. Your calculator can add and subtract fractions with unlike denominators pretty quickly. Just tell it exactly what you want to know. I need to know what negative 3 plus 1/2 is. So just type that exactly in. So negative 3. And then what I'm going to do here is put plus, what is it? Plus 1/2. And I like to, anytime I type a fraction into this calculator, I like to put parentheses around it. So I'm just going to do plus, open parentheses, 1 over 2. Hit enter. You're going to get a decimal. Your calculator just defaults to write all your answers in decimals. But it's also very simple to turn a decimal answer into a fraction by simply hitting the math button. The very first thing under the math function on your calculator is, do you want to turn that decimal into a fraction? So hit yeah, enter. So what this is telling your calculator to do is turn your last answer into a fraction. So when I hit enter again, it tells me what, even in simplest form, negative 3 plus 1/2 gives me what? Negative 5 over 2. So when I put those together, it gives me negative 5/2. So I've got x to the third. Put my x squareds together to get negative 5/2. X squared. Drop down my negative 3/2 x. All right, number 5. Number 5 is as far as I got in my 9 o'clock class, so we'll see if we can get through 6. Let's see. So all of these that I have done so far that has taken this much foiling and this much distribution, I have every single one, I have ended up with degree 3, which means my highest exponent is a 3. And it has taken this much work and this much multiplying to get to degree 3. So when number 5 starts off with the phrase, find a polynomial function of degree 6. That means my end result, after I do all the multiplication together that I've got to do, is going to end up with x to the 6th, which pretty much means double this amount of work. Okay, so degree 6 means I should end up with x to the 6th at the end. So degree 6, let's see what my zeros are. The first 0 is negative 3, but it tells me this 0 has a multiplicity of 3. So that means after my parenthesis or my factor, it's going to have an exponent, right? That's where the multiplicity is. It's the exponent of the factor. Let's see what the next 0 is. 0 of multiplicity 2. And the last 0 is 3 and has a multiplicity of 1. So let's see what this is going to look like all written out. If negative 3 is the 0, what factor did it come from? X plus 3. If the multiplicity of this is 3, that means that's where that goes. The next 0 is 0. Where do zeros come from? Just x's, right? I don't have plus or minus anything because the 0 is just 0. So let's see. I have an x, and its multiplicity is 2. And what's the last 0? The last 0 is 3, which means what factor did it come from? It must have come from x minus 3. And its multiplicity is 1, which is nice. So it doesn't have an exponent. So here's what I got to multiply together. Now remember, I can do it in any order I want. And I'm going to start here. Again, just because it looks like the easiest part of this. If I distribute that x squared to x minus 3, that's not too big of a deal. What is that going to give me? X squared times x is x to the third. X squared times negative 3 is negative 3 x squared. So I've multiplied that one, which means now I just have to multiply this one. But what does x plus 3 to the third power mean? X plus 3 times x plus 3 times x plus 3. So I'm going to forget about this right now and figure out what x plus 3 to the third is going to give me. I don't even know where to go on here. So let's see what all that's going to give me. It's going to give me some answer, and what am I going to do with that answer? I'm going to multiply it times this. So let's see. Multiply these two together first. X times x gives me x squared. X times 3 is 3x. 3 times x is another 3x, and 3 times 3 is 9. Put my 3x's together, so now I have x squared plus 6x plus 9. So taking care of those, I still got to drop down this x plus 3. And after I multiply this parentheses times this parentheses, I'm going to get an answer. And then what am I going to multiply it by? That one. So keeping it organized and neat is going to be a big plus on this kind of problem. So let's see, when I multiply this together, x squared times x gives me x to the third. X squared times 3 gives me 3x squared. Move to your 6x now and distribute it to both of those. So 6x times x gives me 6x squared. 6x times 3 is 18x. And then distribute the 9 to both of those. 9 times x is 9x. 9 times 3 is 27. So now remember, once I clean this up, I've got to multiply it times x to the third minus 3x squared. So let's see, what's going to go in that second parentheses? My x to the third. Because what am I putting together here? I need to put together my x squareds and my x's. So my x squareds are going to end up being 9. And my x's will end up being 27. So let's see, I've got x to the third, 9x squareds, 27x plus 27. Once I multiply this parentheses times this parentheses and clean it up, then I'm done. Look what happens when you do the first. X to the third times x to the third. What do you do with those exponents? When you multiply the same bases, you add their exponents. So this x to the third times x to the third is going to give me x to the 6, which is good news, right? My end result was supposed to be a polynomial of degree 6, which I'm going to be at now, which means I'm almost done. So I did x to the third times x to the third, gave me x to the 6. Now I have x to the third times 9x squared. Remember, add your exponents. So that's going to give me 9 x third x squared is x to the 5th. Now where does this x to the third go? To the 27x. So x to the third times 27x, positive 27 x to the 4th. And my last one, x to the third to 27. So x to the third times 27 is 27x to the third. So I've distributed the x to the third to all of these. Now what else do I need to distribute to all of those? This one. So negative 3x squared times x to the third gives me negative 3. What are my x's going to be? X to the 5th. Let's see, I've got negative 3x squared times positive 9x squared. So negative 3 times positive 9 gave me negative 27. My x's are squared, so that gives me x to the 4th. Keep going. Negative 3x squared goes to the 27x. So what's that going to give me? Negative 3 times positive 27 is negative 81. I've got x squared x, which is x to the third. And then my very last one, negative 3x squared times positive 27. So negative 3 times positive 27 again is negative 81. X squared and no x's, so that just leaves me with x squared. So staying organized is going to be very key. Let's combine our like terms. Let's see. Are there any other x to the 6's besides that first term? No. What about x to the 5th? Let's see, I've got one here and one here. So those are both x to the 5th. I've got positive 9 and negative 3. So that means all together I've got positive 6. X to the 5th. What about x to the 4th? Here's a positive 27x to the 4th. And here's a negative 27x to the 4th. So what happens when you put your x to the 4th together? They cancel each other out. What about your cubes? Let's see, I've got a positive 27 here and a negative 81 here. So when I put my x cubes together, I get negative 54. X cubes. And what comes after x cubes? X squareds, which is just this one at the end, right? That's the only term that has an x squared exponent. So I'll just bring it down. Negative 81 x squared. Okay? All right. Let's do number 6. We'll be a step ahead of the 9 o'clock class, which means we'll have one less to cover on Wednesday. Find a polynomial function of degree 4, which is a little bit good news, right? Because this one was degree 6. So that's kind of telling you how much work you're about to have. So I'm only going to degree 4 this time. So I should end up with x to the 4th instead of x to the 6th. So it's going to be the same process. It's going to give me a 0 and then tell me that 0's multiplicity. Okay. Find a polynomial of degree 4 with negative 1 as a 0 of multiplicity 3. And 0 as a 0 of multiplicity 1. So let's see, negative 1 is the 0, which means it came from x plus 1. Its multiplicity is 3. 0 is a 0, which means it just came from x, and its multiplicity is 1, so it's just going to be an x. So negative 1 is a 0 of multiplicity 3. 0 is a 0 of multiplicity 1. So all I need to do here is the x plus 1 to the 3rd, which means x plus 1 times itself 3 times. So once I get all of that, then I'm just going to have to multiply that final answer times x, which means just distribute an x to that final answer once you multiply these together. So let's FOIL the first two. X times x, x squared, x times 1, 1x. 1 times x is another 1x. And my last 1 times 1 is 1. Put your x's together in the middle. So you'll have x squared. 1x and 1x is 2x plus 1. So now I'll bring down this x plus 1. Distribute here. So let's see, what's this going to give me? Distribute the x squared to both of those. X squared times x is x to the 3rd. X squared times 1, 1x squared. Distribute the 2x to both of those. 2x times x is 2x squared. 2x times 1 is 2x. And distribute the 1 to both of those. 1 times x is 1x. 1 times 1 is 1. So let's clean this up. Any other x cubes besides that one? Nope. Put your x squareds together. 1 and 2 gives me 3x squareds. Put the x squareds together. Now put the x's together. 2x and 1x is 3x. So put the x's together. Now I'll just bring over that plus 1. What's the only thing I have left? What do I, so I've taken care of the x plus 1 cubed, which gave me this. Now what do I need to multiply that whole polynomial by? X. You can either put it in front of it or behind it. Remember, multiplication doesn't matter what order you do it in. So if I'm multiplying this whole parentheses now times this x, what's going to happen? I just need to distribute that x to all four of those terms. And what happens if you multiply something times x? It's just going to gain an x. So x times x to the third will leave me with x to the fourth. There's my degree 4, right? Which is what we're supposed to end up with. X times 3x squared gives me 3x to the third. X times 3x is 3x squared. And x times 1 is x. All right, we will stop on that one and start with number 7 on Wednesday. So again, tedious. There's not anything more than multiplying and combining like terms, but it does take a lot of keeping your work straight. All right, see y'all Wednesday.